All right, guys, today is lesson 7.7. We're doing two things today, missing pieces and scale. We've kind of already done the missing pieces, and you'll see what I mean in a moment. All right, this is what you need on your desk. Paper, pencil, calculator, formula sheet, and your note and homework packet. Note packet, we're going to do a little bit on these 3 pages, 11, 13, and 14. And the homework packet, we're going to do page 10 and 12 to 13. Now, this is at the top of page 11 in your homework note packet, okay? Your formula sheet should be handy right now because you're going to need it. All right. A parallelogram has a height of 10 units. The area of the parallelogram is 120 square units. What is the length of the base? Well, we're going to write our formula right here. We are talking about a parallelogram. So when you look on your formula sheet, parallelogram formula is A equals BH. Get that from the formula sheet. Okay, pieces that we know. Okay, we know that the area is 120 and the height is 10. Well, we're going to substitute that into the formula in the appropriate spot. So A is 120 equals, we don't know what the base is. That's what we're looking for. So we're going to keep B as B. The height is 10. Now, one-step equation. How do we solve this? Well, we divide both sides by 10. And we end up getting B is 120 divided by 10 is 12. And the label is going to be, well, units. It doesn't tell us. Okay. Now, we've done problems like this a lot this year. Now we're doing the same type of thing, but we're using the area formula. Now, here we go. The area of a triangle-shaped monument is 20,130 square feet. The base of the triangle is 22 feet. How tall is the triangle-shaped monument? Well, what formula are we going to use? Well, we're going to look on our formula sheet, and the area of a triangle, we know we're doing area because they said area, and a triangle is 1/2 base times height. Now, what do we know? Well, we know that the area is 20,130, and the base is 22. We're looking for the height. So we are going to take these numbers and substitute them into our formula in the right spots. So A is 20,130 equals 1/2 times the base of 22. We don't know what the height is, so we keep it as H. Now, how do we solve this? First thing I do, 1/2 times 22. You punch that into your calculator and you get 11. So we've got 20,130 equals 11H. 1/2 times 22 is 11. To solve this, now I divide both sides by 11, and I end up with 1,830, and the label is going to be feet. All right, we are not going to do this one. This problem is right below that chart on page 11. So this is still on page 11. All right, it says the perimeter of a rectangular garden is 36 yards. One side has a length of 12 yards. Find the area of the garden. Well, this is a tricky problem. All right, first thing I'm going to tell you to do, let's draw a rectangle. And they're telling us that the perimeter is 36. So I'm writing that right in there. One side is 12. So this is 12. That means this would be 12. To find the area, don't I need the length and the width? Well, I don't know what this is, so I'm going to call this X. And this is also X. So do you see what we did? Perimeter is 36, so I wrote that there. P equals 36. One side is 12, so this is 12. If that's 12, so is this. We don't know this other side, so I'm calling it x and x. Well, how do I find the perimeter of any shape in the world? I add up all the sides. So x plus 12 plus 12 equals 36. On this left side, x plus x is 2x. 12 plus 12 is 24 equals 36. Solve this by subtracting 24 from both sides, and we end up with 2x equals 12. Divide both sides by 2, and we end up with x is 6. So this is 6. We're not done. We want to find the area of the garden. Well, area is length times width. So area is going to be 12 times 6, which is 72. And what will the label be? We're talking yards, square yards. All right. That is solving problems kind of backwards, okay? And we've done that. This is the second part of the lesson. Turn to page 13 in your notes. This is page 13. This is taking area problems and applying something we did earlier this year, which is scale, okay? Let me just tell you something. Scale means an item is either exactly like it should be, but either shrunken down or made large. So this is a blueprint of a basketball court. Clearly, this is not an actual basketball court, right? Because look at how small that is. This is what we call a scale drawing, okay? A scale drawing. This is a lot smaller than the actual court. You could have a scale model of a car. Anybody that does model cars, they're shrunken down cars. So sometimes a scale model is smaller, sometimes it is larger. Like if you had a scale model of an atom you can't even see. A model is bigger than the actual. So this says, Mr. Gautier has asked you to calculate the actual area of his half court that he wants to build next to the parking lot based off of this scale drawing from the architect. Based on the scale drawing, what is the actual area of the half court? Guys, write this now. You need to convert measures before you find the area. Super important area. Now, this is going to be a review of proportions. Those of you that are new to my class, this is going to be something that you're going to need to learn. It says here, 1 inch on the scale drawing is 15 feet of actual length. 1 inch is 15 feet. So we are going to set up our proportion, and we are going to set up a cheater fraction, inches over feet. Those of you that are new, make sure you are taking good notes. And if you're not new, you also need to be taking good notes here. So 1 inch is 15 feet. So the first part of our proportion, 1 inch over 15 feet, equals, look here, this is 1 2/3 inches. Where does that go? On top. We don't know how many feet, X on the bottom. Now, that's our proportion. Inches over feet equals inches over feet. And that's going to convert this height of this basketball court into feet. Well, let's cross multiply. When I cross multiply, 1 times X is X. 15 times 1 2/3 If you punch that into your calculator, you get 25, and the label on that is going to be feet. So I like to, in my drawings, when I'm doing one of these problems, this is 1 2/3 inches. That is 25 feet. I am going to write that right underneath it, so I know that that is how long that side is. Now, we need to convert 2 inches into feet. I think most of you could say, well, if 1 inch is 15 feet, wouldn't 2 inches be 30 feet? But if you don't know that, set up a proportion. Inches over feet. 1 inch is 15 feet. And this is 2 inches. That goes up top. This is inches over feet. And X feet. Cross multiply. 1 times X is X. 2 times 15 is 30. So it's 30 feet. So our model is 1 2/3 inches by 2 inches. The actual court is 25 feet by 30 feet. Now, I'm going to change color here. Based on the drawing, what is the actual area of the half court? Well, this is a rectangle, so the formula that we would use is area equals length times width, but we're going to multiply 30 times 25. Whoops, 30 times 25, length times width, you're using the feet, is 750, and the label on that is going to be square feet. Square feet. Now, this next part says, if it costs $2.75 per square foot of paved macadam, and Mr. Galtier's budget is $2,000, can we complete the project? Well, we have 750 square feet to put macadam down, and each one costs $2.75. So we're going to do 750 times $2.75. And when you punch that into your calculator, you get $2,062.50. And he budgeted $2,000. Does he have enough? No. Not enough budgeted. And budgeted means he only wants to spend $2,000, but it's going to cost a little bit more. All right. This is at the bottom of page 13. Page 13. A scale drawing is used when an object is too large or too small to represent at its actual size. That's what we were just looking at. In a scale drawing, the dimensions of the object have been either reduced or enlarged. The scale factor is the constant of proportionality between the dimensions of an object and the corresponding dimensions of the scale drawing. It's actually really easy. Watch this. Josh made this scale drawing of a rectangular flag. He wants to produce a second flag drawing of the flag, but he wants it to be larger than this one. And he's using a scale factor of 2. What will be the side lengths of the new drawing? Well, let's look at this one. If I look on this grid, this side of the flag is 1, 2, 3, 4 units. That's 4 by 1, 2, 3. 4 by 3. Well, we're doing larger. So larger, and our scale factor is 2. We're going to multiply by 2. So 3 times 2 is 6. So our new height is going to be 2, 4, 6. Did I count that right? 1, 2, 3. Wait. Sorry, guys. My eyes are deceiving me here. I want to make this 6 units high. Let me count. 2, 4, 6. So that's 6. And 4 times 2 is 8. 2, 4, 6, 8. I didn't do a good job. 6 by 8. So if you are doing a scale factor of 2 and it is larger, you multiply. But what if I said I wanted it to be smaller? Smaller, you would divide by 2. Okay? Larger, you multiply by 2. Smaller, you divide by 2. All right. This one, scale drawings include a scale. The scale compares the length on the scale drawing to the length of the actual object. It can be written as a ratio, which is also a proportion. Scale units do not have to be the same. For an example, a map could compare centimeters to meters. So let's look at this picture. Here's our scale. I'm going to move this over. This drawing shows the floor plan of an exhibit room in a museum. What is the perimeter of the actual exhibit room? Okay, well, before we can do that, we need to convert all of our measures to actual. So this is 13 centimeters, and here's our scale. Whoops. Our scale is 1 centimeter is 3 meters. So we are going to set up our proportion. And we're going to do centimeters over meters. Now, guys, I don't think you're going to have to set up a proportion for every one of these. Let's figure out the math by doing a proportion. So 1 centimeter is 3 meters. 1 over 3. Centimeters over meters equals, let's do this one first. 13 centimeters. That's going to go on top. X meters on the bottom. Cross multiply. 1 times X is X. 3 times 13 is 39. So this side is 39 meters. Now, what did we actually do? Didn't I just multiply the number by 3? Okay, I really just did 13 times 3. So once we figure that out, I'm going to do 3 times each one of these numbers. So 8.1 times 3 is 24.3 meters. 13 times 3 is 39 meters, because we did that up here. 8.6 times 3 is 25.8 meters. Notice they are now meters. And 10.3 times 3 is 30.9 meters. Now, I have converted all my sides into meters. How do I find my perimeter? Well, I add these all together. So my perimeter is going to be 39 plus, I'm going to go around in a circle, 30.9 plus 25.8 plus 39 plus 24.3. And when you add all of those together, you get 159 meters. All right, so guys, the key here is setting up a proportion using your scale, converting the measures, and then using the new measures to find either the perimeter or area. All right, guys, show Mr. Izzy the pages in your note packet right now and follow along in your Google Classroom.